This is a part 2 for chapter polymerization, and this is type growth polymerization. Now we look at the relation between the chain length and the extent of the reaction. First, we get to know the number average degree of polymerization, which is dp. Characters develop a simple equation for relating the degree of polymerization to percent coefficient of monomer for type 1 and type 2. And it is useful to know the dp for type 1 or type 2 in indication of the average chain length. Okay, for type 1, dp equal to no over n. What is no and n? It is actually the n initial, which is the original number of molecule present in a monomer, and n is the number of all molecule remaining after time. Okay, so C initial here is the initial concentration of the monomer, and the C below is the concentration of one of the functional groups. Okay, in type 2, the dp is equal to half of the total number of Na plus Nb divided by n, whereby Na is the initial number of A functional groups and Nb is the initial number of B functional group. And N is the number of molecules chains at the at P. Okay. And C here also the concentration of one of functional group. Okay, don't worry too much about the equation. I will explain later. Okay, characters develop a simple equation for relating number average degree of polymerization of all molecule to percent conversion of monomer for type 1. Okay, I will explain the equation in this writing. Hope you can understand it. So as we know that P equal to 1, P is the extent of the reaction, which is the chain length, also known as the chain length, and P, as mentioned in the equation, is equal to n initial minus n divided by n initial. So you can multiply P with NO, so we can get NO P equal to NO, it is n initial minus n is equal to n initial minus with n initial n P, and we can get the n initial 1 minus P. So according to the characters equation, n over n initial is 1 over P, 1 minus P. This is according to the characters equation. Hence, you can say that the xn or the dp, degree of polymerization, is 1 over 1 minus P. So we have to twist it. Okay, I will continue right here. Twist the formula and we get n initial over the n equal to 1 minus P. So xn is 1 over 1 minus P. Okay. So dp equal to xn. dp and xn is the same thing, which is the degree of polymerization, and it is how the equations actually did. So P is the reaction conversion, also known as the chain length or the extent of reaction. And N initial is the initial molecule, N is the total molecule after a given period of time. And this equation demonstrates that in step growth polymerization, very high conversion are necessary to achieve practical molecular weights. So I will show you another example. So let's say if you have 98% of conversion. So find the degree of polymerization that the polymer has achieved. So you just substitute xn equal to 1 minus p. And this one, which is p, extent of the reaction, it must be less or equal to 1. So we can get the value here, 1 minus 0.98. So means that the degree of polymerization achieved for 98% of conversion is 50%. So xn is 50, not percent. It has no units. Okay. Okay, now we look at the relation of degree of polymerization with number average molecular weight. So Mn is the number average molecular weight, and M initial is the molecular mass of repeating unit. Okay, dp for step growth polymer when used non-stoichiometric quantities of monomer type 2, and the degree of polymerization is affected not only by the yield but also the molar ratio of the reacting functional groups A and B for type 2 monomer. If the quantity number of mole for monomer functional group A and B is not in stoichiometric balance, the dp can be expressed by the equation dp equal to 1 plus r divided by 1 plus r minus 2rp. Okay. So this is the stoichiometric imbalance given by the nominated by the r, and r is the element measure, which is the measure the stoichiometric imbalance. Okay, R is actually given by NA initial divided by NB initial, and R value must be equal or less than 1. R is actually the number of molecular chain. Okay, and it is also as a, we call it as a stoichiometric imbalance. So there are two names for R: number of molecular chain and also stoichiometric imbalance. Okay, the degree of polymerization will be regulated if the monofunctional reactant added in the mixture, and the dp can be expressed by the equation 1 plus r divided by 1 plus r minus 2rp, and Nm is the number of mole for monofunctional group. Okay, don't worry too much about this equation. What I can explain about this equation is actually the number of molecular chain R is equal to Na initial divided by 2, and 1 plus 1 over R minus 2P. So we just substitute the dp equal to N initial over the N into this equation. So if the R equal to 1, which is equal to dp, is 1 over 1 minus p. So when monomer is completely used up in the polymerization, we assume that the degree of the p, which is the extent of the reaction, is equal to 1 plus r divided by 1 minus r. So don't worry too much about the equation. Now we look at the number average degree, which is given by xn, and the weight average degree, which is given by the xw. So xn is the number average degree and xw is weight average degree. Xn is equal to 1 over 1 minus p and xw is 1 plus p over 1 minus p. So don't ask me why this equation is like this, because this is the rules of the equation created by the scientists before this. And the molecular weight distribution, also known as PDI, is xw over xn equal to 1 plus p. So if the question asks you to calculate the MWD or PDI, you must know the value for xw and xn so that you can get the p-value or the MWD. And if the question asks you to relate the MW and MN in terms of P, so you can relate it by by the substitution of the formula from MN from here, okay, from XN, XWP, XW. Okay, now we look at the question. Reaction of hexamethyldiamine and salicylic acid will produce 9.610. Of the 99.8% reaction, the molarity in the system was 0.0024. Calculate the degree of polymerization if initially the equimolar monomer were used in the reaction. So you can try to calculate to answer the question. Okay. First question, you need to calculate the degree of polymerization, which is the dP. The given information, it gives the 99.8% reaction. What is it? So 99.8% is the conversion. So you just substitute by using the formula Xn equal to 1 over 1 minus P. So this one is the P value, which is you must convert it to less than 1, which is 0.99. Okay, 0.99. Okay, you can get the value and calculate degree of polymerization if initially 1m hexamethyldiamine and 1m salicylic acid were used in the reaction. So this one also they want to calculate the degree dp also, and try to solve this three question. All right. Okay, we proceed the polyfunctional angulation in the next video.